is 𝘁cie𝗶𝗰𝘀, and I will present you some slides about confidential computing. Here in part 1, I will introduce some motivation for confidential computing. So, confidential computing is about protecting applications. And so therefore I introduce confidential computing with the help of an application. This application is owned or operated by an application owner. And an application typically has some data, some code, and some secrets, like the keys to encrypt the data on disk or to encrypt network connections. And so I, as an application owner, I want to protect the data that's processed by my application. I want to protect the codes. For example, if that's Python code, I want to make sure that nobody else can just copy my Python code, modify it, and use it for their own purposes. And of course, I want to make sure that nobody can decrypt the encrypted data that my application uses or processes. And in addition to application owner, we have also the role of clients. So clients use the application of the application owner. They connect, typically with the help of their browser, to the application, and then they can access their own data. And let's look at the context of electronic health records and electronic health applications. And there, typically, we have more stringent requirements regarding access to the data. So we might have the requirements that the clients that connect to the application, so here we have 3 clients that connect to the application, they all have their own data, and we might be required that the application isolates the data of the client. So if even in case there would be a bug in the application, that if client 1 accesses the data and breaks out of the code of the application, this client 1 cannot access the data of the other clients, like client 2. So from that perspective, we need to isolate the data in some way that, despite having some bugs in the application, we can protect and isolate the data of the individual clients. And in some cases, we even have to make sure that the application owner has very limited access to the data. So the application owner should not be able to just access the data of the clients in clear text. Of course, in some cases, there needs to be some access to the data. For example, the application owner might hire some staff that helps the clients to, say, correct certain entries in the database, like the address, or get help with certain parts of that application. So therefore, maybe some staff members, they have access to part of the data of a client, but not all of the data. And what part depends on the application itself. And of course, we have also some infrastructure and service staff members, and they should not be permitted to access the data of the application. And so one way to isolate the data of the different clients would be to encrypt them with different keys, and each client kind of has a key that is derived from something like the client ID. And one of the problems that we need to address is if the infrastructure staff member has root access on the computers, on the servers on which the application runs, this staff member might see the keys that are used to encrypt the data in clear text, because that staff member might just access the memory. If the staff member has root access to a server, then the staff member can access all the data that is in the main memory. So we need to make sure that the keys that are used to encrypt the data of the different clients are protected. And we also need to make sure in this example that maybe we need multiple keys to access different parts of the data, because certain staff members get access to parts of the data of, say, client 3, but not all of them. So we need to somehow have some key management that allows us to grant partial access to some of the data, and we have to make sure that the keys are protected in such a way that the application owner nor staff members can gain access to these keys. So this is kind of given to us by the requirements of our application. We have here also some business problem that we need to address, because often this application owner might need to run that application, the eHealth domain, but this application owner might not have their own data centers, might not have infrastructure staff to run actually the data center nor the application, and might not even have application staff members that can set up that application. So typically such an application consists of many software components, often connected as via REST APIs these days. So we have microservices that we connect to one big application, and for that we need lots of competence to be able to set that up. And often I call that a service provider takes care of that, and there are staff members of the application service provider that helps the application owner to set up that application. And so the service provider, they need to develop maybe some of the services, but often they need to do lots of configuration to make sure that the application is properly set up and can be properly operated. And the operation is typically done in the context of some data center. These days, often multiple data centers, and we have infrastructure staff at the data center or the cloud provider, and we need to make sure that neither the infrastructure staff nor the service provider staff nor the application owner can access all the data and the code and the secrets. So we have actually a difficult technical problem. So let's zoom into that technical problem. So we have these keys that we might use to isolate the data of the different clients. And if the infrastructure provider has root access on the servers, as I mentioned, they might have also access to the keys that are in memory. So that means if I'm an admin on a server, I can copy all the data from memory, and I can extract the keys that I use to encrypt the data. Data that might be encrypted on disk, that might be transferred encrypted via the network. I need some keys, and these keys, they live in main memory. So now I have a picture for the disk. So if the data of client 3 is written out to disk, it will be encrypted by the application and stored on encrypted disk. And if we don't encrypt in the application level, but only on the disk level or on the infrastructure level, so if the operating system encrypts the file system, then of course all the infrastructure staff members that have access to the keys of the operating system would see the data unencrypted. So we have to make sure that the application can write out encrypted data such that infrastructure provider and the staff members of the infrastructure provider cannot see the data in plain text, nor can they see the keys in plain text. So that means keys managed by the infrastructure provider cannot be trusted. We have to make sure that the keys that are used cannot be viewed by the infrastructure provider. Also, the application service provider staff is not trusted in our application, so if the application service staff member could access keys via dashboard, say of the key store, then we have a problem that we need to address. So if we have some key stores provided by the infrastructure provider, we need to make sure that the keys in there cannot be used or retrieved by staff members of the infrastructure provider nor by the application service provider. And therefore, we have a technical problem that we need to solve. And that brings us to the threat model and the implication that we need to address. So I will introduce why we trust the CPU in a later section of this presentation. So first, the assumption is that we trust sometimes the CPU, meaning we trust the CPU after what we call attestation, which I will present in a later chapter of this presentation. But let's see who we trust first. As I already mentioned, we don't trust the infrastructure provider in the staff members of the infrastructure provider. Of course, one could argue, well, we could review the hypervisor, the operating system, Kubernetes cluster that is managed by the infrastructure provider. We could maybe audit the source code, but these days things change so fast. So you have updates that might be rolled out every day or every week at least. And so it's really difficult to keep up with all the source code changes, to audit them, to make sure everything is okay and there's no backdoor in the infrastructure. Also, there are lots of configurations that could be used to provide access to the application's data, code, and secrets. So therefore, one not only needs to review the code, but also the complete configuration and how the system is set up, in what way the keys were generated, and what ways the keys can be used. So it's a really complex infrastructure typically that we use for our applications, and it's really difficult to make sure that all the requirements regarding our application confidentiality, integrity, and consistency are satisfied. So therefore, our assumption is that we cannot trust the infrastructure provider. It's just too complex and too difficult and too time-consuming to ensure that the infrastructure is trustworthy. As I mentioned, the application owner needs the help of a service provider that helps to set up the application, and that service provider might be able to change some application code, might configure the services of the application. This service provider might even write some parts of the application code, and from that perspective, it is difficult to protect the application from the service provider. But we still need to do that because the application provider must not be able to access the data and some of the code of the application owner. And so we need to find a way to ensure the data is protected. And that is extremely difficult. And our approach for that is as follows. We use confidential computing to make sure that our infrastructure and service providers cannot access the application while it is in use. So these providers cannot access the code, cannot access the data, cannot access the secrets, in particular the keys used for encryption. And we can, in this way, protect the confidentiality, the integrity, and the consistency of the application. Of course, we also, in this way, want to exclude all the adversaries that might attack our application. We might need some more protection regarding the adversaries, but that is also addressed in a later section of this presentation. And the application owner, as I mentioned, owns the application and might operate it or delegate the operation to an external service provider. But the application owner also needs to be prevented to access all the application's data. So from that perspective, we also can use and need to use confidential computing to protect the application from the application owner itself. And that seems to be an impossible task. And we show in a later section of this presentation how we can do that.